We can move to the last presenter. She is from France, Anaëlle Vayssière, and she works at AQUABIO. The title of her presentation is Multimillennial Change of the Cher River Morphology in the Northern Western Europe, the role of intrinsic watershed components versus the role of climatic and human forcing. Anaëlle?
Yes, can you hear me?
Yes, we can hear you very well. And please, you can share your screen, your presentation.
Okay. Up. So can you see the slide?
Yes, maybe you can try to okay.
It is a full screen?
It's full screen now, and we can hear you very well.
Okay, thank you.
So please go on.
Okay. Good afternoon to all of you. I would like to thank the organizer and you for listening my presentation. My presentation deals with the change in fluvial morphology of the Cher River during the late glacial period and the Holocene period. Concerning the regional setting, the Cher River Valley, the Cher River is a medium-sized lowland French river, and the research I present involves two study areas located in the Middle Valley. This study area are called Bigny and Teyou. You can see them in a note in red on the map. The catchment of the Cher River is also located at the interface between different climate influences that have evolved over time. Indeed, both of the study reaches are located on the southern margin of the Paris Basin, with a periglacial inherited landform inherited of the pleniglacial period. And nowadays, it is located at the interface between continental and oceanic climate influences also. Therefore, the Cher River can be considered as an intermediate step in both north-south and east-west position in France. Currently, the Cher River displays a sinuous path, as you can see on the picture above. And the width of the valley allows the preservation of a very large number of paleo meander, denoting the shifting of the water course over time. On the pictures below, we can see a former channel, nowadays totally filled, and as you can see, it is now a terrestrial environment exceptionally flooded during big floods, such as on the photo which I've been taken in June 2016. It is interesting because the Cher River has displayed a very low mobility for the last 200 years, as it has been demonstrated by one of my colleagues, Thomas Desprez. Now, concerning the specificity of the studied period, the temporal scale corresponds to the last 15 millennia, and it involves two main external controlling factors. First, the climate change, and more specifically the climate oscillation that occur during the pleniglacial, late glacial, and early Holocene period, which is associated in Europe with several changes in fluvial morphology and processes. During Holocene, and more specifically during the second part, this part of Europe experienced an increasing anthropogenic forcing. In the Cher River catchment, we could identify, forest clearance are known, are identified for fire history from the late Neolithic, which corresponds to the 5 millennia before present. And we also focused on hydraulic engineering work that expands during the medieval, modern, and contemporary period, and we will see it will have great control on fluvial morphology during historical time. Concerning the methodology, we propose an approach based on two different scales. On one hand, at the macro scale, we propose a morphostratigraphical approach with borehole, geophysical data, and archaeological witnesses. We study 102 borehole, 230 meters of outcrops, and geophysical cross-section were made on the field. In addition, 54 borehole and archaeological data from documentary research were added to that dataset. And then we propose to question the paleo-environmental signification of fluvial archive and the spatial distribution using GIS and mainly the analysis of LIDAR DEM. On the other hand, at the macro-scale analysis, we focused on the study of paleo-channel filling that provide good environmental record. In this study, it corresponds to 13 core mechanically sampled, and some of them were studied using multi-parameters analysis such as grain size, geochemistry, and one core was studied with palynology to provide information on the vegetation history. The chronological framework is based on 40 radiocarbon dating and 7 optically simulated luminescence dating. The result we get depicts two main topics corresponding to two distinct periods. The first topic is the smooth response to climate forcing during the late glacial and early Holocene. Then the second topic corresponds to the readjustment of a sinuous and meandering river during the second half of the Holocene. As you can see on the figure, there is a long sedimentary hiatus between the two studied periods. So I will present these topics aiming to understand the complex dynamics that control a current low-energy meandering river by identifying the respective part played by climate change and human pressure on fluvial morphology, and by questioning the key role played by intrinsic components of the basin, such as slope, valley width, inherited landform, and sedimentary body. Concerning the first topic, which corresponds to the older period, we first conduct a topographic approach on the LIDAR DEM, as you can see on the figure. On this figure of the study reaches of Tenue, we can see the Holocene meander belt in a light color, but I will talk about it later. We above all see a set of small elongated mounds extending in the direction of the flow, and that appear here in brown and yellow. If you can see my arrow, it's like this one, this one, this one, and this one. And there are the witnesses of the pre-Holocene period. In order to better understand this landform, we made two sedimentary cross-sections of the valley bottom, not here in black. On this cross-section, we were able to identify coarse pre-Holocene sedimentary formation overlain by early Holocene deposits. As you can see here in dark brown here and here. On a smaller scale, we have highlighted a series of paleo channels of different size, separating the elongated mount I just talked about. And it is interesting because all of these paleo channels are at the same topographic level. Among them, two have provided the organic material suitable for radiocarbon dating, and they are framed in red. They give us information on what happened during the late glacial period. These channels were cut between the 15 and 13 millennium before the present, which corresponds to the milder interstadials of Belling and Harrod period. Multi-parameters analysis shows that the base of the filling of this paleo channel is initially very organic during this milder period, and then it becomes more mineral and carbonated, probably due to the transition to the drier and colder younger Dryas. Finally, this sedimentary sequence seems to reflect little evidence of instability of the gradation process of Paleochannel in response to that strong climate oscillation during this period. It leads us to hypothesize that the Cher River experienced weak morphogenetic processes during this period. The morphological change we can reconstruct shows three main stages. First, before the Bulling and Darrud period, there is a concentration of flow within former wide-braided ridges inherited from the Pliny Glacial, but without a significant entrenchment of this channel. There is no incision identified during this period. During Bulling and Darrud period, which correspond to the milder climate, these lateral channels are cut off and they are immediately filled with a peaty and organic silty deposition. During the younger Dryas, which is drier and colder, these lateral paleochannels are filled with lithogenic deposition and experience dewatering processes, especially during the early Holocene.
Anaëlle,
Yes.
you have 1 minute.
Oh. Okay. Well, we consider it as an original response to the late glacial and Holocene transition because there is a lack of incision and terrace formation. All the floodplain deposits of the late glacial are at the same topographical level as the Holocene or even lower. The factors that may explain the lack of strong morphogenetic processes are proposed by comparing with fluvial adjustment during the same period in other study areas in France. These study areas are located further north and west for most of them, and the Cher River depicts a smooth and progressive morphological adjustment. The proposed explanation are first the physiognomy of the valley. We hypothesize that the low gradient of the valley bottom could not give sufficient energy to the river to rework previous deposit and shape new river landscape. And then we hypothesize that a location further southern and western may have led to less pronounced periglacial condition, especially during the younger Dryas. In addition, in that region of France, there is poorly developed loess cover, and it may also have limited the supply of thin sediment in the valley bottom. If there is no time, I can just go to the conclusion because I will not have time as if I understand good.
Yes, please. It's indeed very interesting, and I'm sure that many of the participants would love to hear everything you have to say, but time is running and...
Yes, I understand. I'm sorry for the bad management of time. Just in 2 words, during the second half of the Holocene, we identify a large number of paleo meanders, and it is a predominant fluvial pattern during this period, and it seems to have been continuous during the last 6 millennia until the medieval era, when the fluvial engineering work stop the meandering mobility that have been maintained until this period because of the high erodibility of the riverbank. To summarize.
I'm sorry. I am receiving messages from the participants that they love your presentation and they ask to go on for, so please, you may use a few minutes more, let's say 5 minutes to put everything together. It was not only me that I loved what you said, but also the rest. So please go on.
I'm sorry, I go on the presentation or I go to the conclusion?
Nikki, you have the microphone turned off.
I'm sorry. Yes, I'm sorry.
Okay.
So you have 5, 6, 7. I don't know why it is. It turns to mute by itself.
Okay.
Okay, so you have 5, 6, 7 minutes the most. So you know what you have to say. You choose what is worthy for the audience.
Okay. Okay. Thank you for that time. So as I said, we could identify I could identify and date 13 paleomeanders in both study area, as you can see on the LIDAR DEM map. We also conduct sedimentary cross-section of the valley bottom in both study area, and in Bigny the above and in Tegnou below. And we could conduct a large number of dating on the paleo channel filling. And what is interesting on this cross section is is that the main part of the valley bottom is constitute of coarse sediment, such as sand and gravel, and it is overlain by a thin silty layer, and that silty layer will date around the 12th century. So it is no, it's older than that, but this process accelerates around the 12th century, so it's quite recent. All of this analysis conducted on fluvial archive lead us to conclude to the long-term persistence of meandering processes during the second half of the Holocene until the 12th and 13th century. Indeed, the meandering pattern seems to have been continuous because 1 to 4 cutoff were recorded in every millennium in both study area, and no other fluvial pattern have been recognized during this period. The main explanatory factor for that long-term persistence of active and meandering process is, as I just said, the low resistance of the riverbank, because the floodplain deposits are weakly cohesive. As I said, it mainly consists in sand and gravel covered by a thin silty layer. We assume that the gentle gradient of the floodplain, as well as the slope at the scale of the catchment, may have limited the landscape connectivity, and it may have prevented the valley bottom from an abundant silty deposition, or at least increase the delivery time. And this occurs in a context of land use change that would have increased sediment delivery, but here it's not the case. As I said before, in this region, there is a poorly developed loess cover, and it probably helped to explain the low thickness of thin deposits in the valley bottom. After the 12th and the 3rd century, the fluvial system experienced laterally stable phases. Indeed, no paleomeander younger than this period were identified in either study area, and the Oxbow Lake environment is gradually disappearing. It is likely that the many hydraulic structures located in the riverbed and that expand since the medieval era are the main explanatory factor for that stability. Indeed, such hydraulic engineering work such as mill, weir, and bank protection would have inhibited lateral migration by preventing sediment transports. To conclude, we highlight the morphological change of a European river driven by climate variation, but also by human pressure. Nevertheless, we also show the key role played by slope, sediment source, and inherited sedimentary bodies. We highlight the key role of gentle gradient and sediment furniture in the late glacial and early Holocene smooth morphological adjustment, which can be considered as original in the French region. We then highlight the key role of inherited landform and inherited sedimentary bodies, and the gentle slope in the maintaining of a Holocene meandering process. And during historical times, the key role of hydraulic engineering work by inhibiting lateral mobility after the medieval era. And it also led to the significant drop in Oxbow Lake environment. In this context, we would hypothesize that the Cher River would be able to recover active meandering processes if engineering rock were removed because of that low resistance of a bank. And thank you for your attention, and I'm sorry for the time.
Thank you, Anaëlle, for your presentation. The topic is very, very interesting, and you have showed a very long evolution of these multimillennium of these rivers. So congratulations for your work.
Thank you.